Good morning and welcome back to my channel, and today we're going to be doing my first Olympiad problem, and this is problem 4 of the 1962 IMO International Mathematical Olympiad. So the question, just solve the equation cos squared x plus cos squared 2x plus cos squared 3x is equal to 1. Now, first of all, this looks like quite a fun question because it's just got increasing amounts of x in the cos, so I just think it's an exciting problem. So, first of all, I'm going to split this up. So I'm going to do cos x squared plus cos 2x squared plus cos 3x squared is equal to 1. I'm doing this because it makes the next step a lot more, it makes it make sense a lot more. So first of all, let's split these three things into just cos, or cos squared, rather than just powers of cos x. So, the way we do that, so cos x just obviously stays as cos x. Cos 2x, by the double angle formula, is identical to cos squared x minus sine squared x, which is identical to 2 cos squared x minus 1, because that's cos squared x minus 1 minus cos squared x. So the negative cos squared x turns to another cos squared x, and the positive 1 in the bracket turns to a minus 1. Now, cos 3x is interesting because I doubt many people will know the actual form of it. So the way we're going to do that is we're going to derive it using Demarv's theorem, which is something that you learn in year 2 further maths if you're doing a side-by-side learning, so maths and further maths in the same year. So the way Demarv's theorem works is any complex number z to the n is equal to cos theta. Obviously, we're using x in our original situation, but I'm using theta here because this is Demarv's theorem, plus I sine theta to the n. And what Demarv's theorem states is that that is identical to cos, that's not right, to cos n theta plus I sine n theta. And the way this is going to help us is that we just want this n to be 3. So we're going to cube this expression here, and then we're going to take the real component of it. So cos theta plus I sine theta cubed is equal to, so cos cubed theta plus 3 I cos squared theta sine theta minus 3, because the I will be squared now, minus 3 cos theta sine squared theta, and I'm going to write the next bit on the next line, minus I sine cubed theta, because I cubed is just minus I. And I'm going to pair these with real and imaginary components. So that's going to be cos cubed theta minus 3 cos theta sine squared theta plus I 3 cos squared, I'm going to write this on the line below, plus 3 cos squared theta sine theta minus sine cubed theta. Now we only really care about this imaginary component, no, this real component, so we're just going to do a bit of simplifying with that. So I'm going to write real component, and that is, so cos cubed theta minus 3 cos theta sine squared theta, that is identical to cos cubed theta minus 3 cos theta 1 minus cos squared theta by cos squared plus sine squared is equal to 1, so by Pythagoras. And what this means is that that is identical to 4 cos cubed theta, because this minus here and this minus over here, they cancel out, with at least with the cos squared bit, minus 3 cos theta. So that's what cos cubed theta is. So now, working back to our original expression, we had cos theta, not cos theta, cos x squared plus 2 cos squared x minus 1 squared. I wrote that up here, didn't I? Yeah, I did. Plus 4 cos, that's written in an over, so that's not helpful. 4 cos cubed x minus 3 cos x squared is equal to 1. And now we're just going to do some algebra autopilot. So that's going to be cos squared x plus 4 cos to the 4x minus 4 cos squared x plus 1. This plus 1 will cancel with the 1 on the other side, so I'll do that in the next step. Plus 16 cos to the 6x, or large powers, minus 24 cos to the 4x. It's 24 because 4 times minus 3 plus times 2, because it's 2ab. Plus 9 cos squared x is equal to 1. And now we're gonna cancel those ones, and then we're gonna pair up our terms. So I'm gonna do wiggly lines for cos squared. I'm gonna do straight lines for cos to the 4, and there is only 1 cos to the 6. So that's gonna be 16 cos to the 6x minus 20 cos to the 4x plus 6 cos squared x is equal to 0. And now I'm going to make a substitution that u, so let u, this just makes it easier for me to visualize, let u equal cos x. Then we have 16 u to the 6 minus 20 u to the 4 plus 6 u squared is equal to 0. And so obviously one of the solutions will be u equal to 0, and it's a repeated solution. And so now I can divide by that u squared, because I've counted it as a solution. So that'll be 16 u to the 4 minus 20 u squared plus 6 is equal to 0. I'm going to divide everything by 2. So that'll be 8 u to the 4 minus 10 u, not u squared, yeah, u squared, plus 3 is equal to 0. And now I can factor this as a quadratic because this is an even function. because if we replaced u squared with a, this would just be 8a squared minus 10a plus 3. So what we're going to do is we're going to do this by inspection. So we're going to do u squared bracket here, another u squared here, and that is equal to 0. And I'm doing that because I leave space here and here, because that's where I'm putting my coefficients and other stuff. So, what is going to multiply to make 3? Well, 3 is a prime number, so it's either going to be, it's got to be 1 and 3. Minus or plus, I can tell it's a minus by this coefficient here. It's a minus 10, so it's going to be minus on both of those. Now, what do I need to multiply to make 8? So that would be a 1 and an 8, or a 2 and a 4. And in this case, a 1 and an 8 will not give me a minus 10 if I multiply them by the minus 1 and the minus 3. So I'm working some combination of 2 and 4. And what I can see is that it will be this way round, because 2u squared times minus 3 will be minus 6u squared, minus another 4 will be the minus 10, which is what we want. And so what this gives me is that u squared is equal to a half, or u squared is equal to 3/4. And then u is equal to 1 over root 2, or plus or minus, u is equal to plus or minus root 3 over 2. And that's quite handy because those are known trig identities, because I know that u is cos x. So cos x is equal to plus or minus 1 over root 2, or cos x is equal to plus or minus root 3 over 2. And now I'm gonna draw a big cos graph just so that I can visualize this. I apologize for the drawing in advance. I was never any good at art. So we're gonna do it in little sections. Oh gosh. I don't really like that last section, but anyway, we're going to work with it. So, actually no, I'm not going to work with it. That is disgusting. So, if cos x is to be 1 over root 2, we know that 1 over root 2, cos x equals to 1 over root 2 is 45 degrees. So that will be around this point here. I'm going to do that in red, actually. In red. So that will be here. And then its counterpart will also be over here. And then here, and so on. And so what that will be, so 45 degrees is just pi by 4. So for the cos x equal to 1 over root 2, or plus or minus 1 over root 2, that produces an x equal to pi by 4 plus n pi by 2. Because if you add 90 degrees to your first solution, to your 45 degrees, or rather, if you add pi by 2 to your pi by 4, you will get down to this solution here. And so on, you can get to this other solution here. So plus n pi by 2. Basically, you're plussing multiples of 90 degrees for n belonging to the set of integers. I haven't specified positive or negative, so it will go both ways. Next solution we've got to deal with. Cos x is equal to root 3 over 2. And also, this solution, will it deal with it? No, it won't. Well, we've already said that it can be equal to 0. So that's our first first solution that we must deal with. And in order for it to be equal to 0, sorry, I'm going to deal with that solution first. Cos x equals 0. That means that x must be equal to pi by 2. Actually, no, just n pi by 2 for n belonging to the integers, because yeah, I think it will be just n. No. It'll be pi by 2 plus, that's not a plus, plus n pi. And that will be the same in the negative. No. It will work in the negative direction. Plus n pi for n belonging to the integers. So I'll write that again, for n belonging to the integers. And then the final solution, cos x is equal to root 3 over 2. That means that x, so plus minus, x is equal to plus or minus pi by 6 plus, I think it's n pi. Because that will get you your first solution. I'm just going to rub those out. Our pi by 6 will be down here, and we'll have 1 over here, and that will be that's minus pi by 6. So in order to get to this one here, which is our next solution, that's pi, and so here to here is pi, and here to here is also pi, and then you get the same across, so that's also pi, and that's also pi. So therefore it's plus or minus pi by 6 plus n pi. And those are the solutions to this equation. Thank you for attending this video, and I look forward to seeing you all next time.